A potentiometer is a 3-pin device, and between two of the pins there is some resistive material. Oftentimes it's carbon, and it could be like real thin metal, like real thin wire, and it'd be like wire wound. That would be called a wire wound potentiometer. But whether it's carbon or thin wire or whatever it is connecting. Two of the pins are connected by that strip of carbon, let's say, for the one we're going to be using. And then there's a third pin. Oftentimes it's the middle pin, but you don't want to assume that. You'll use your own meter to find out for sure what the orientation of the pins is. But the middle pin oftentimes is what we would call the wiper, and it's connected to a moving sliding contact that has the ability to just slide along and make contact with this resistive strip here. So they call this the wiper, and that's pretty much the whole story. You have fixed resistance between two pins, and you have variable resistance. Do you see that? Between the wiper, the center pin in this case, and either of the outside pins. And maybe it's worth thinking about that for a second. What's the difference? Because I can tell you, sometimes you use all 3 pins, sometimes you just use 2 pins. You always need the center or the wiper pin. That's the sliding contact. But what if I pick these two to connect to? So if I use these, do you see that when the wiper is here, that would be counterclockwise, right? This would be my counterclockwise pin, wouldn't it? It's telling me that's where the wiper is. When I rotate this shaft counterclockwise, that would be this direction, it will bring it to the counterclockwise pin. So counterclockwise, if I use these 2 pins, counterclockwise, I would have 0 ohms between these 2 pins. And then as I turn it clockwise, the resistance between these 2 pins increases. And then it's just the opposite for over here, right? So this would be my clockwise pin. In other words, when I rotate this wiper clockwise, and there's a shaft, I mean, this is the shaft that rotates and takes the wiper with it, and it can rotate all the way around. When I'm turning it in a clockwise direction, it'll come all the way to here and stop. There's a mechanical stop that prevents it from going round and around. And it'll go to, and it rotates to about, I mean, what would you call that? Maybe the 5 o'clock position, and here maybe about a 7 o'clock position, right? Here's 12 o'clock, dead center. So that's about the mechanics of it for most. I mean, there's variations, but for some of them. And also I should mention, this would be for a single turn pot, you just go one way or the other. You can get variations where it takes, 3 turns or 5 turns or 10 turns or 15 turns or 20 turns to get the wiper to move all the way over to here through its whole range. So you get high resolution then. And that's sort of sometimes they have a little gear mechanism where you rotate the shaft, and there's a gearing mechanism that just moves inches this along in a very small amount. So there's lots of variations mechanically too. But let's just focus in here on the basics of when you go counterclockwise, you're at 0 ohms with this pin in the middle, and when you go clockwise, of course, you've brought it all the way to this pin. So those pins are identified as the counterclockwise pin, the clockwise pin, and this would be our wiper here. And we've got choices now, because if we wanted to use it as a variable resistance, we would use 2 pins, but we have a choice, right? Do we want the resistance to increase when we turn it clockwise? Which 2 pins would we use? it would be these two, right? Resistance will increase as we go clockwise. As we rotate clockwise, the wiper moves away from the counterclockwise pin and resistance goes up. So we would, for clockwise increase in resistance, we would use these two. If we want resistance to increase when we turn it counterclockwise, of course, we'd use these two pins. Or another way of saying that same thing is maybe there's a circuit where you need resistance to decrease when you rotate clockwise. Which two pins? These. That would probably be the two I would use if I was going to create sort of a little variable resistance that controls the brightness of our little lamp. It's intuitive for the operator that the lamp would be brighter when you turn it clockwise. We're used to turning things clockwise to turn up the volume or increase the brightness of a lamp. So I would pick these two because as I move clockwise, the resistance decreases all the way to 0. So the lamp would be full bright here in the clockwise position. So that's where I want to use those two pins. Okay. Just to show you a lot of the different mechanics and so on. And what we just talked about would really be an example of using a potentiometer or pot as a variable resistor, also known as a rheostat. If you're just using two of the pins if you're just using two of the three, you're really using it as a variable resistor or rheostat. We'll get into using all three pins in the next chapter, but there you would be using it as a potentiometer. We have a couple potentiometers or pots in our parts box, and let's just grab this large one first. That'll be an easy one to inspect and compare, with our sort of theoretical drawing. So pull this one out and let's look at a couple things on it right away. Of course, it does have 3 pins. So, and there they are, 1, 2, 3. Here's the shaft that rotates, so it's going to sit like this. That's exactly what we've got. And if we look closely, we can see some markings on this one. And can you see B1K? So the B doesn't tell me anything, but well, it might. I'm not sure that I know what the B is there for. But the 1K jumps out at me as 1000, and that is the actual resistance of the resistive strip. It's a 1K pot that we have here. If we're not sure about that, if we feel like, well, that's a good guess, but we'd like to confirm it, the ohm meter will do that for us. So let's put an ohm meter right on the 2 outside pins. Well, we are making an assumption, aren't we, that the 2 outside pins are the fixed resistance part. Let's do it though, and then we'll see. But let's take our ohm meter and explore this a little bit to see exactly that if we're right about that being a 1K pot. So we've got our meter. We're going to set it to ohms. I've got the mini grabber test leads, and I'm just going to hook them right onto this potentiometer, right on the 2 outside leads, because that's my first guess. And I'll see if I'm right. And again, I might be, might not be. You don't want to assume anything. And it looks like I'm getting a 1K reading. Now, it's not going to be exact. You might be like 0.945 or something. In this case, I'm a little over, but that's typical. They're going to have some tolerance. They're not going to be spot on. So that looks good. Now, how can I check to see that I'm on the fixed resistance? Well, I can rotate the shaft, and if the resistance doesn't change, that tells me, right, that I'm on the fixed resistance. And in fact, it looks good. And while we're doing that, while we're spinning the shaft, you can see that we can go about, from 5 o'clock to 7 o'clock. It's upside down, actually, kind of. But let's take the shaft all the way counterclockwise, okay? And can you see what resistance I should expect? I should see 0 ohms then between the counterclockwise pin, right, and the center. And that's what I've got, and it might be it looks like I got an ohm or something. Might not be exactly 0. But right here is the position of the wiper position is actually right here now, right? And of course I can rotate the wiper and I'll just see resistance between this counterclockwise pin and the wiper, I'll see the resistance increase, right, as I go clockwise. So let's do it. And you can do this. You can follow along. The meter is a little lag there while it catches up, right? I'll probably hit not probably, I will hit a midway point. So let's see if I can get the wiper to stop. I'll stop rotating it right at 500 ohms or 0.5K. You know, if I can, the meter's a little sluggish, but something around there. And look, no surprise. Just the wiper, the pot itself kind of shows us we're at the halfway point as far as the rotation of the shaft. So I've got my 500 ohms, and right now my wiper is, of course, right here, straight up and down. I can keep going, right? And I should get all the way to 1K, because what I've done is I've hooked on to the counterclockwise pin, this outside pin, and I've taken the shaft all the way around to the full length of that resistive strip. I'm essentially across the resistive strip now because I took the wiper all the way over to where the clockwise pin is. Yep. I can check it, of course, the other way. I can hook on to the clockwise pin and I'll see the exact same thing happen in reverse. Now I'm at 0 ohms when I'm full clockwise. Yep. And I'm going to increase resistance as I rotate counterclockwise. Again, there's my halfway point. Go right through that. Yeah, all the way over. This is the one, like we said, if I was going to use it to vary current in a way that I want, you know, current to increase clockwise, just to be more intuitive. This is probably the 2 pins. These are the 2 pins that I would use, right? Because as I go clockwise, resistance decreases. So current would be increasing, and that's these 2 pins. But you always have the choice, and it all comes down to what you're trying to do in the circuit, and you can choose then the appropriate pin that's maybe the most intuitive feel for the operator. And again, this is just showing it being used as a variable resistor where we're only looking at using 2 pins, not all 3. Later, we'll do the potentiometer and show you how you use all 3 pins for that. Okay, the other thing to mention, though, is it is a 1K pot. And we could put another description on there. It's a single turn 1K pot. But it's also what you would call linear taper, which just means that when we were at the midpoint, in fact, there was 500 ohms on either side. In other words, if you're a fourth of the way around, you'd be at 250 ohms, and halfway you're at 500, 3/4 you're at 750. So the resistance increases linearly or by the same amount as you rotate. But there are other types of potentiometers that might be what they call audio taper and logarithmic. So there's log taper. These are not linear tapers. These are maybe you know, at the halfway point, you might only be 1/4 of the resistance, for example. So you can get all different types, but the one we have here is the simplest to follow, I think. But the audio taper, the log taper, those are ones that they do come in handy. It has to do with the fact that if you were using something for a volume control, the louder it gets, the more it takes to gain an appreciable difference in loudness. Another way to say that, the more you have of something, the more it takes to make a significant difference. If you have $1 and you get $1, that's very significant. If you have $100 and you get $1, it's not as significant. If you have $1,000 and you get $1, even less significant. So to make a significant change, the more you have, the more change you need. Okay, so that's the whole idea behind a logarithmic pot or audio taper. It is the way it works in nature. With sound volume, if you went from like 1 watt to 2 watts, you could hear the difference big time. And if you went from 2 watts to 3 watts to 4 to 5, so on, those are changes you would hear. But if you were already at 50 watts, you can't tell the difference between 50 watts and 51 watts of sound power. So so the audio taper is going to make up for that. It's going to start small, and then the higher it gets, the more drastic the change, in resistance. I hope that makes sense to you. Yeah. That's the whole thing with logarithmic taper. It doesn't go 1, 2, 3, 4. It goes 10, 100, 1,000, 10,000. So you get the idea. So we've got a 1K linear taper single turn pot. And I'm okay if you want to hack into it. Sometimes it just helps you remember, what you really have there, what a pot really is. I had the idea, this one, we can destroy this one. It's okay. I find a flush cutter's the easiest way to do this, but what I'm going to have to do is get these 4 tabs off so I can get the back off. And I guess it doesn't necessarily destroy it. You can always put it back together. That's true. I'm just prying the tabs up with this. The needle nose is a little too blunt, so I'm using the flush cutters actually to get underneath those tabs and pry them. That one's being stubborn, so yeah, come on. There we go. And then if you have all 4 tabs pried up, the back should just drop right off of this thing. And we can see the actual mechanics. Maybe I'll try to get in a little closer on that. Let's see if I can focus. All right. I don't know. This is the wiper here. And the center pin's connected to that wiper. Maybe I can come even closer. Hang on a sec. All right, well, we'll see what we can see here. But like I say, here's the wiper itself is right here. And the resistive material is this gray carbon. It runs all the way around. The gray carbon patch or strip goes from this terminal all the way to that terminal. So let's see. Let's move it through one rotation. Do you see the metal contact? Right now it's touching the one outside terminal. Right now when I rotate, do you see how that contact just slides along that piece of carbon? See if I can get to the other side here. But yeah, it's just making contact on there, and now I'm touching the other outside contact. Okay, so you might find some other potentiometers if you have, well, that this black plastic's a little bit in our way, so it's not quite as obvious. Maybe I can find another one just to show where that's not in our way. Okay, so here's one I found that is a little easier to see. So if you see the wiper, right now it's on the outside contact there, and I'm getting 0 ohms on my ohmmeter. I got my ohmmeter tracking along here. Now I'm moving off of that, and I'm onto the carbon strip. Do you see? And the resistance is starting to go up. Now the carbon strip, I'm at 100 ohms of carbon, right? Going around, probably wait for the ohmmeter to catch up. I'm at the about the midway point on that carbon strip, and there I am at 500 ohms, right? Because I'm on these 2 outside pins. Center pin's the wiper on this pot too. Keep going, the resistance goes up, up, up. I'm just dragging that contact along on the carbon, and I get all the way over to here, and I've got the full length of that carbon that goes all the way around here. So I've got the 1K. Of course, if I would move my test leads over to here, I'm back at 0 ohms, right? Yep. Remember, that's the wiper in the middle. There's the wiper, and here's the outside, one of the outside pins. I'll go back the other way. I'm moving off the wiper, and now I'm dragging across the carbon back to the midway point, and I go all the way over to the other pin, and I now have the full 1K that I'm back to again. So yeah, this one's a little nicer to see. Of course, if I'm on the two outside pins, in this case, those are the fixed resistance. Doesn't matter where the wiper is, does it? I'm not connected to the wiper. I'm just connected to the resistive strip of carbon. Yeah. When you take the back off, it's possible to just keep spinning around. That's not the case. If the back's in place, you have a stop in one direction and a stop in the other direction. Okay. Here's an example of a wire wound pot. We had said it doesn't have to be carbon. It could be like thin wire. And here's a contact that's sliding along, making contact with that real thin, wire that's providing the resistance. So you have different length of that wire depending where you're making contact on it. Yeah. So that'd be a wire wound. Those, like I said, are if you need higher wattage, you're probably going to get into a wire wound design. And here's an even better example. This would be a high wattage, 50 ohm variable resistance, just as you rotate this, variable 25 ohm resistance. This would be something you could use to test out, power supplies. It can handle up to 1 amp going through, so low current power supplies. It would be what you call dummy load for them. And if we look on the flip side, we can see that they're wire wound pots and being used as variable resistances, but the resistance is between these two lugs here. You flip it over and you'll see the wire wound pots that are sitting behind here. So there again, there's that contact that slides along a different length. And it's not that the wire is so thin, but it is not a great conductor. So it might be some kind of iron or something rather than copper, perhaps, but some kind of metal that's not as conductive. And so you get resistance out of that. And notice, of course, we're only using the two of the 3 pins in both cases. And when I turn it clockwise, I'm gaining resistance. That's probably the most intuitive, right? So on the face, moving clockwise gets me all the way up to 50 ohms. And that's how you would probably do it to be most intuitive. So, but there's, just a good example. They're wire wound, and they're actually on a ceramic substrate so that the heat buildup, doesn't melt plastic. If it was just plastic, it could get too hot for that. So that's the kind of stuff you might see when you get into the higher wattages. We have a couple other examples that we can look at in our parts box, and we'll be using some of these in circuits too. This is a rather bulky looking thing. It's an example of a multi-turn pot, so we can examine that one. There are smaller versions of multi-turn pots. They don't have to be this large. I just figured it's an easy one to see visually, but don't think that they can't be more compact. And then we've got these little blue pots. These are single turn pots. The markings that you can see on them, let's see what we can see. Some are harder to see than others. I think there's one that might be, well, those are 3 that don't. Sometimes they have it. Okay, here this one has it in black ink. And if we zoom in, if we zoom in on that, let's see if we can see that. Can you see a 201? That means 200 ohms because it's 20 and then 10 to the 1. So it's a digit multiplier. So a 201 is telling me I have a 200 ohm pot. Let's see what some of these other ones are. If we can see them, it's hard. There's a 502. That's telling me a 5, a 0, and 2 more zeros. Or 50 times 10 to the second. 50 and 2 more zeros sounds like 5K, right? So that's a 5K pot. And when I say that, I'm talking about the fixed resistance of the potentiometer. This one, what do we have? Looks like 1 0 and 3 more zeros, 103, right? 10K. It's a 10K pot. And this one is 102. So 1 0 and 2 more zeros. That sounds like a 1K. We can leave that one out. We can experiment with that one just because it happens to match. And we can also look at this multi-turn. So let's examine those next. So it's the same game. This is, I think, a 2 watt. I'm trying to remember. But this might be somewhere in the area of 2 watts that it can handle before it would get hot and burn up. This might be more like a 1/2 watt potentiometer. It's smaller. It's a PC board mount, or works great on breadboards. But it's still got the same 3 pins, and we can look at those. We can check those out. As far as the shaft, it's just you're going to have to use a little screwdriver to adjust this one. There's just a little slot in there to turn it. And as opposed to, here this would be more what they call a panel mount potentiometer. You'd have a nut, a hole and a nut. You bolt it onto a panel. You put a knob on there. You're probably familiar with those. There might even be some markings on here that tell us the clockwise pin and the counterclockwise pin. We could try to see. I don't know if I can get in that close. Let's see what we got here. Yeah. Do you see a little CW there? So right there. There's my CW. If I can hold that still. And they have them numbered too. They are calling pin 3 clockwise. Even if I didn't have that clockwise marking, I could pretty much figure that out, right? Because of what we have done so far. I mean, obviously, if I take the screwdriver in that slot and I turn this, I'm sliding it along until when I turn it clockwise, it rotates until I have 0 ohms. The wiper is actually touching this pin, this clockwise pin. But they mark it here in this case. I mean, if it wasn't marked, it wouldn't be hard for me to figure out, which one. And even if physically, mechanically, you didn't remember, how to find which one's clockwise or counterclockwise, your ohm meter, of course, can check that out for you. So speaking of that, let's get an ohm meter hooked onto it and sort of run it through its paces. So I had my ohm meter with the mini grabber leads, and I hooked them onto these little pins. And then I thought better of it because those pins were bending, and you know what? They can only bend so many times before they break. That's solid wire there, and it breaks after a few bends. So thought better of it, and I thought, of course, let's just put this on a breadboard and then use the breadboard test leads. I think that'll work out much better for us. And actually, I'm going to put it on with this kind of orientation here to help me sort of stay oriented like with the physical side of it. So I've got my ohm meter set up. I'm going to put my ohm meter across what I'm guessing is the 2 outside, the fixed resistance, the 2 outside pins. It's a good guess, but it is a guess, and I don't like to assume anything. So I'll put it on there, and I can see my ohm meter showing me that it's a 1K pot, 0.98. That's reasonable. Let's see if it varies when I turn the shaft, and it does not. So that's proof that that I'm sitting on the outside terminals, here and here. Okay. Or I shouldn't say outside, but I should say the fixed resistance, because they're not always physically the outside. Now I'm going to move this to the center pin, and I'm thinking that's got to be the wiper. And in fact, it looks right because I'm fully counterclockwise right now, and I'm at 0 ohms because I have the wiper rotated all the way around counterclockwise. So I have this connection right here. Now I'm going to move it through the resistive band, the strip of resistance. So as I turn, resistance is going up. I can see when I get to the middle, there's that slot. And look, I'm right there, straight up and down at the 12 o'clock position. I'm at my 500 ohms. And that's because it's a linear taper. And then I keep going And I get all the way around to that 5 o'clock position here, and I'm at that 1K. So that's how I can check it. I can see that it's working. You know, it's giving me that variable resistance. I can, of course, check the other pin. So now I'm on this outside pin and the middle pin, and I'll get just the opposite effect, right? Now when I'm clockwise, I'm at 0 ohms. And when I go counterclock, we're close to it, right? I mean, so that's reasonable. And then when I go counterclockwise, the resistance goes up because I'm moving this way, increasing the resistance. Just have a little screwdriver here to do that. And get all the way over to 1K. Yep. Breadboard's a little friendlier for these PC type pots. I was looking for an example of a multi-turn pot in that same size as the one we just looked at. I can't find one. I know I have them around here somewhere, but what I did find though is that same one I was looking for. It's already on a board here, but just to show you size-wise, it doesn't have to increase in size very much. I mean, here's the one we were looking at, and it's a single turn, and here's a multi-turn one, and I think this one, if you can see the markings on it, it looks like a 202, so it's a 2K pot, and it just has a little screw here. And what happens is you turn this, and it might be like 10 times. You have to turn that around 10 times to get all the way around the resistive strip. What's happening is you're still rotating the wiper around a strip, but there's a little worm gear here and a wheel. And as you turn it, it just rotates that wheel around the strip slowly. So yeah, so multi-turn, I mean, you can get, like I say, 10-turn pots. This might be a 10-turn. When you get to the end of how far you can go, they'll usually, there might not be a hard stop, but there's a little clicking sound, a little tick that you can listen for to tell you you've got there. Of course, your ohmmeter can tell you when you've got there too. But that's just to give you a glimpse at a multi-turn. Wish I had one to stick on the breadboard, but I couldn't find one. We do have this multi-turn potentiometer in your little box of parts, and you can play around with this one. It's a bulkier version, but I picked it, like I say, because it's easy to see what's going on. So if you can see when you turn the shaft on this one, it's that same sort of worm gear that just takes quite a few turns to get from one end of the resistive strip to the other. So here, the strip of carbon starts at one end and finishes at the other, and then your contact actually moves along that strip of carbon. I think it's pretty easy to see. Maybe we can zoom in a little bit so you can play around with it. And I mean, you can see what's going on. You know, you just takes quite a few turns. You can count them. It's basically one turn each time I'm flipping that through my fingers, right? You could count those. There I'm at the end. You hear the ticking? It's as far as it can go. Use your ohm meter to figure this thing out. It's a good example of maybe not wanting to assume. I mean, because you might say, well, my first guess is that the wiper is here at the middle pin, and then the outsides of the resistive strip are maybe here and here. And I'm pretty sure that's not right, even though that might be a first guess. In this case, our guess would be wrong. And another thing we can look at is the markings. Let's see, what do you make of them? Can you pick out some numbers that mean something to you? I'm seeing 25K, so I'm going to guess it's a 25K ohm fixed resistance that I'm sliding across. And it looks like linear. That's my guess. But I don't have to guess, right? I can get my ohm meter on the case. So if I'm thinking it's a 25K, I might just look for that. And my first thing might be, the outside pins, I can see those pins are oxidized, by the way. So I might buff those up a little bit if I wanted to be a little better at estimating, at getting it. But I'm going to go into where the shinier part of that pin is. Out to the outside, it's pretty oxidized. Okay, so that looks like not a bad, I don't know why it's beeping at me. That's not a bad guess. I think we're on the money there. The 25K seems like the right marking. let's see where we're at here. I'm on the two outside pins. Let's see if the resistance varies when I rotate this and move move the wiper. So I'm moving the wiper. Am I moving the wiper? Nope, I got to move it the other way. No, I'm moving it. Uh-oh, look. The resistance is in fact changing. So I'm not on the fixed resistance, right? So this is a good one for you to experiment with. You got to find out what the pin out is. So they would call that ohming it out or pinning it out. Same thing you would do with a switch. You know, get your ohm meter on there and see what's going on. I don't know. What's another good guess? What do you think? I mean, looking at it physically, I feel like one end of the resistive strip has to be here. And maybe I just picked the wrong pin here. So maybe the other end of the resistive strip is not all the way at the outside. It is in fact here. That's what I would go for next as something to try. And then I'm starting to even think that makes a lot of sense, because maybe this pin is connected up here to the wiper, which is what's being slid along there. So let's try it. Let's see if I can move this wiper all the way along its length of travel. Get my hands out of the way there, right? Maybe I'll spin this around, okay. I'm gonna just move it all the way along, okay. And I do not see resistance changing, right? Okay, so there's a good indication that in fact, that's the fixed resistance. Those two pins are the fixed resistance. The other one is the wiper. And then I'd have to answer, again, it's a good exercise with your ohm meter, because I'm wondering, is that the clockwise or the counterclockwise pin, right? Where my red lead is the wiper, if I didn't lose track here. So let's see if the black lead is on the counterclockwise or the clockwise, and so on. But you can do this. I don't have to drag this out. You can find this all out, right? I'm going clockwise and I'm going to 0 ohms. All right, so I think I've identified the clockwise pin. I'm going to move this, and this would be the counterclockwise pin if I'm right? And you can do this all exercise yourself. I mean, this video, I don't mean to torture you, but I'm going counterclockwise now. So let's see if I'm going to hit that counterclockwise pin with 0 ohms. And in fact, reasonable. You know, it's hard to say what's reasonable, right? If you don't know, but get off that oxide for one thing. I mean, we're talking about 25,000 ohms. So 50 ohms, 54 ohms is where 0 ohms is. Yeah. So, all right. So, I mean, without beating it to death, you can pin that out, but that's a great little exercise. Turns out the middle pin is not the wiper. I think I've got it right. I think this is the wiper. When I was flipping it around there, I might have lost track, but I think that's it. You can check it out though for yourself. See if I'm right about that. So, all right. So it's a good one to fool with. And finally, let's just have a little fun. We can try using one of these in a simple circuit. I know we've done it before, but not bad review. And now that we know really what's going on inside, let's see what we can do. So we're going to take a look again and see this one that we were using. If you remember, it was focus on that. It was a 102, if I can get the light on there, right? And that is going to be a 1K. So that's a little high of a resistance for our little lamp. If you remember, we're down in the hundreds of ohms really when we're dealing with that lamp. So we better stay in that range. And we do have some of those in your kit for you. So you're going to need to find the little potentiometer that says 201. And you can check it with your ohm meter, but that is a 20 and another 0. So it's a 200 ohm pot. And we're going to use it not as a potentiometer, but as a variable resistor. We're just going to use 2 of the pins. And like I said, later we'll learn how to use all 3 as a pot. But for now, we're just going to use it as a variable resistor. So find that one, the 201, and we can get it right up on our ohm meter in case you weren't sure of the of the markings, or if yours doesn't have real clear markings, sometimes they're hard to see. But I can get on those outside pins and prove it out pretty quickly. There it is. So close enough, 192.3, that's my 200 ohm pot. I'm going to use it as a variable resistor. So, and I want to use it to vary the brightness of a lamp. So I'm thinking, again, intuitively, turning clockwise is what I want to make the lamp get brighter. So I'm going to use the clockwise pin, because if you remember, when I go clockwise, I'll hit 0 ohms on the clockwise pin, full clockwise. And that's where it'll be the brightest, right? That's where current will be the most. So with all that in mind, I mean, I guess we can try to spot that clockwise pin, or you could find it with your own meter. But I see it marked on there. Again, the focusing is a little tough, but if you can get that, there it is, right? That little CW, that's this pin. Even if you don't have the marking, you can see, I think, right? You can see the mechanics of it. I mean, when you're turning this slotted thing clockwise, let me get it all the way clockwise. Oh, it is already. So when I turn it clockwise, I'm moving the wiper over to this side. So there it is. That's my clockwise pin. I'm going to use that to vary the brightness of a lamp. So remember, it's this, it's the middle pin, and this one. Focus. Yep. Middle pin and that one. That's all I need. I don't need this other outside pin. I just need 2 pins. One of those 2 needs to be the wiper, of course. The other one determines the direction of rotation that I'm using, you know, as far as what makes sense. So I have that. That's going to be my variable resistance that varies the current in the circuit for my little lamp. And let's get this little circuit built. I mean, I can put 3 volts to it, so I'll put my batteries in series 8ing. I got my positive voltage. I'm going to bring that right to the wiper. And you know what? I kind of don't like those wires being in my way, so I'm going to move this down. But I have to kind of know where that node is. If I'm off by a node, I'll find it. I am off by a node. I found it already. I want the wiper and the clockwise pin. Okay, and there I've got it, and there's the lamp. And now I think I can have some fun, right? Let me start off counterclockwise and bring up the brightness, right? Okay, there it is. It's dim, but I got my adjustment, and I know we did this before. I just wanted to, worth repeating, I think. So there's my lamp. Oh my goodness. And I'll turn it clockwise without blocking it. This is difficult. So there it goes. And now there's my full bright clockwise and my dim. So we just wanted to repeat it for you because we had done this, I know, but now we know this even that much better, this component. Maybe one more thing we can't resist doing is, since we know how to use our ammeter, let's go ahead and get that in the mix. It doesn't matter where I put the ammeter, but I do have to open up the circuit and get the ammeter into the circuit. This is an easy spot to insert it. I'm going to break open the circuit, get the current to flow into my ammeter, back out of my ammeter, and return to the circuit. So I've essentially completed that circuit again. I got to remember to turn this to milliamps, and off we go. So now I've got it under my thumb like a technician, not just a hobbyist. I mean, I was kind of having fun using the variable resistor to, you know, vary the brightness of the lamp, and that's cool, and I like it. And now, though, I've even got the ammeter involved, so I really feel like a technician, because actually that is exactly what we're turning into when we start getting all this equipment on, right? So now I got a view not just of the lamp varying brightness, but I got the numbers to prove it too. So, you know, I'm starting off at low brightness and I'm around 10 milliamps, 9.44 milliamps. I'm going to go halfway around just for fun. There I am at like 100 ohms. See how the current's going down? And the lamp, wait, what am I talking about? Current's going up. It's hard not to block anything. So I'm rotating, I'm halfway around, current's increasing, increasing, increasing. Yep. So I got 2 visuals, if I didn't have my thumb in the way. Lamp's bright, and there's my current. I'll go halfway and get out of the way. There's roughly 100 ohms because I'm halfway through a 200 ohm band of resistance. And I'm at 12 milliamps and that brightness and so on. So you get the idea. But I'd like you to have that feel of it where, I mean, now that is turning into more of a technician exercise. I mean, we're not just watching it visually, watching the lamp go brighter and dimmer, but we're watching the numbers go up and down. So good practice, not bad review for the ammeter too, huh? All right, we'll call it there, and we'll have to do another short video just showing you the schematic symbols that are used for a potentiometer, a variable resistor, a rheostat. So that is its own little mini video for sure. This is not the schematic symbol. I think you know that. And the schematic symbol actually deserves its own 10-minute video just to explain the schematic symbol for a potentiometer. And also then there's some variations if you're using it just as a variable resistor. There's variations in the schematic symbol, and there's a couple different options that way. So we'll show those to you in another separate short video.